Hey everyone, welcome back to our channel. Today, we're diving deep into some groundbreaking space news. There's new evidence suggesting that Miranda, one of Uranus's lesser-known moons, might have a hidden ocean capable of supporting life. This discovery could change everything we know about potential life beyond Earth. So, if you're fascinated by space exploration, the search for extraterrestrial life, or the secrets of our solar system, stay tuned because this is going to be a journey you won't want to miss. Miranda is one of Uranus's moons, and it's a place that has long intrigued scientists. Compared to other moons, Miranda is quite small, measuring about 470 kilometers in diameter. But what really sets Miranda apart is its bizarre terrain. Think cliffs and valleys far steeper than anything here on Earth. These formations suggest that Miranda may have gone through intense geological activity in its past. This combination of size, distance from the sun, and geological complexity has made Miranda a prime target for studying potential subsurface oceans. Despite being icy and seemingly inhospitable, Miranda holds secrets beneath its surface, which might just be key to understanding more about the habitability of moons and other celestial bodies. So, how did scientists discover evidence of an ocean on Miranda? Recent data from various missions to Uranus and its moons has hinted that there could be a vast liquid water ocean beneath Miranda's icy crust. Scientists have used complex models and past data to predict this, focusing on the gravitational forces exerted by Uranus on Miranda. The tidal forces from Uranus may create enough internal heat within Miranda to keep a layer of water from freezing completely. This heat could help sustain a subsurface ocean that, in turn, might harbor the conditions necessary for life. This discovery has added Miranda to the growing list of icy moons in the solar system. The idea of a liquid ocean on a small, icy moon so far from the sun is remarkable. The key factor here is what scientists call tidal flexing. This phenomenon occurs because of gravitational interactions between Uranus and Miranda, causing the moon to stretch and contract, generating enough heat to keep water in a liquid state under the ice. It's this potential for warmth, alongside the liquid water, that raises exciting questions about what could survive in such an extreme environment, perhaps even microbial life forms. The big question, could life actually exist on Miranda? Well, for life to thrive, it needs three key things: water, an energy source, and a stable environment. Miranda appears to have all three. Its ocean could provide the water, and tidal forces could provide the necessary heat and energy. The fact that life on Earth exists in extreme environments, like deep-sea hydrothermal vents and under Antarctic ice, gives scientists hope that life could survive on Miranda too. While any potential life forms on Miranda would likely be simple organisms, like bacteria or archaea, the possibility of discovering life in such a remote part of our solar system is thrilling. It could mean that life is far more common in the universe than we once thought. What does this mean for future space exploration? The discovery of a potential ocean on Miranda makes it a prime candidate for future missions focused on exploring icy moons. NASA and other space agencies are already discussing missions that could take a closer look at Uranus and its moons. These missions could include orbiters equipped with advanced radar to penetrate Miranda's icy shell, and possibly even landers that could analyze surface conditions. The hope is to confirm the presence of an ocean and, who knows, maybe even signs of life. This new evidence about Miranda's ocean could help guide the next generation of space missions and may bring us closer to answering the age-old question: are we alone in the universe? Subsurface oceans, like the one potentially beneath Miranda's icy shell, have become a hot topic in astrobiology. Why? Because these hidden oceans provide isolated environments where life might thrive, shielded from harsh space conditions. Unlike planets closer to the sun, moons with subsurface oceans aren't reliant on sunlight. Instead, they're warmed by tidal forces, as is suspected on Miranda. For astrobiologists, subsurface oceans represent a new frontier in the search for life, potentially hosting ecosystems that differ greatly from anything we know on Earth. Could Miranda hold clues to life forms adapted to conditions utterly unlike our own? Tidal heating is crucial to keeping Miranda's ocean in a liquid state, but how does it actually work? Tidal heating occurs as gravitational forces from Uranus stretch and compress Miranda's interior, generating friction and, subsequently, heat. This process may seem subtle, but it's enough to create warm pockets in the icy crust where water can remain liquid. Similar processes happen on moons like Jupiter's Europa and Saturn's Enceladus, both of which are thought to have subsurface oceans. Without this tidal heating, Miranda's ocean would likely freeze, making it uninhabitable for any potential life. Miranda's surface is one of the strangest landscapes in the solar system. Featuring enormous cliffs, deep craters, and unusual terrain, it's been called a Frankenstein moon by scientists. These features suggest a history of intense geological upheaval, which might indicate past periods of tidal flexing and heating. Some scientists theorize that this geological activity could have cracked the icy crust, allowing water from the interior ocean to reach the surface. The resurfacing and refreezing of water could be what created Miranda's bizarre landscape, hinting at an ocean that may have existed or still exists beneath the ice. Europa and Enceladus are two of the most famous icy moons suspected of having subsurface oceans. But how does Miranda compare? Unlike Europa and Enceladus, which orbit Jupiter and Saturn respectively, Miranda orbits Uranus, a relatively unexplored giant planet. Miranda's smaller size and different composition make it a unique case study, while Europa and Enceladus show clear signs of plumes, jets of water vapor that suggest active oceans beneath the ice. Miranda hasn't yet revealed such activity. Studying all three moons could provide insight into how subsurface oceans form and whether they might all support life. If life exists on Miranda, what might it look like? Since the moon's environment would likely be dark and cold, any organisms there would need to survive without sunlight, relying instead on chemical reactions for energy, a process called chemosynthesis. On Earth, chemosynthetic organisms are found in deep-sea vents, which are dark, high-pressure environments. Similar life forms, such as extremophiles, might exist on Miranda. These hypothetical life forms could be simple microbes or bacteria capable of surviving in extreme conditions, potentially opening our minds to a variety of non-Earth-like life forms. Exploring a subsurface ocean on a distant moon is no easy feat. Miranda is over 1.8 billion miles from Earth, and the technological requirements to probe beneath its icy crust are daunting. Missions would need specialized equipment, including ice-penetrating radar, and perhaps even cryobots robots designed to melt through ice layers. Another challenge is power. Miranda's distance from the sun means that solar panels would be ineffective, so scientists would need to develop alternative energy solutions. Each technological breakthrough brings us closer to unlocking Miranda's secrets, but the challenges are significant. Future missions to Miranda would likely rely on advanced robotics. Unlike Earth, where human missions are possible, Miranda's extreme environment requires fully autonomous robotic explorers capable of navigating icy terrain, drilling through thick ice, and possibly even diving into subsurface oceans. These robots would need sophisticated AI systems to adapt to unexpected situations, as real-time communication with Earth would be delayed by hours. Robotic missions to Miranda could set the stage for even more advanced space exploration, pushing the boundaries of what we're capable of achieving in remote, challenging environments. The Voyager 2 spacecraft is the only probe to have visited Uranus, passing by in 1986 and providing us with our first close-up look at Miranda. Voyager's images revealed Miranda's strange cliffs and ridges, sparking curiosity about the moon's unique geology. Although Voyager didn't carry instruments capable of detecting an ocean, its findings inspired interest in Uranus's moons and set the stage for future missions. The discoveries from Voyager 2 remind us that even brief encounters with distant worlds can yield insights that fuel decades of scientific inquiry. Space telescopes like the James Webb Space Telescope, JWST, and the upcoming Nancy Grace Roman Space Telescope could play a role in studying Miranda. While these telescopes won't be able to directly detect an ocean beneath Miranda's surface, they might help scientists better understand the moon's composition, temperature, and surface features. With the JUST's advanced infrared capabilities, astronomers may gain insights into the potential for subsurface oceans, not only on Miranda, but on other distant moons in the solar system as well. Miranda's orbit around Uranus could be key to understanding its subsurface ocean. The moon's elliptical orbit creates variations in gravitational pull from Uranus, which is essential for generating tidal heating. Interestingly, Miranda's orbit isn't perfectly stable. It has been influenced over time by gravitational interactions with other moons. These gravitational nudges may have contributed to the internal heating necessary to maintain an ocean. Studying this interaction can help scientists understand how orbits impact the geological and thermal history of moons like Miranda. If Miranda is confirmed to have an ocean, and especially if it contains signs of life, it would impact astrobiological theories across the board. Currently, scientists look for habitable zones around stars, where liquid water could exist on planetary surfaces. But a habitable subsurface ocean on Miranda could shift the focus to celestial bodies far beyond traditional habitable zones. Such a discovery would suggest that life might exist in more diverse conditions than previously thought, reshaping how we search for life in our solar system and beyond. NASA has expressed interest in exploring the Uranian system with proposals for missions that could launch in the coming decades. These missions could include orbiters and even landers to explore Uranus's moons, with a specific focus on Miranda and Ariel, another intriguing moon. If approved, these missions would provide the first in-depth look at Miranda and could include instruments specifically designed to detect signs of an ocean. These future missions have the potential to bring us closer to answering whether Miranda has the ingredients necessary to support life. In our quest to understand the solar system, each discovery adds a piece to the puzzle, and Miranda is no exception. Its icy crust, potential ocean, and unusual geology make it an invaluable subject of study. Miranda's potential for harboring life could have implications for our understanding of other icy bodies across the cosmos. Studying this enigmatic moon could lead to insights into the formation and evolution of moons and planets, helping us build a more complete picture of the solar system's complex dynamics. The search for life in the universe is one of humanity's most profound questions, and moons like Miranda may hold the answers. As space agencies consider increasingly ambitious missions, we may soon explore moons and planets beyond our own. Advanced propulsion systems, robotic explorers, and AI-driven technologies could be key to future exploration efforts. By targeting moons like Miranda, we may one day look back at these early speculations as the first steps in humanity's journey to discover alien life. There's something inherently thrilling about the idea of a hidden ocean on a distant moon. Miranda's icy surface, concealing a possible ocean, invites us to imagine what secrets might lie beneath. The idea of life existing in such an extreme environment challenges our notions of what's possible. Whether or not we find life on Miranda, the exploration of this enigmatic moon taps into our primal curiosity and inspires us to keep reaching for the stars. The mystery of Miranda is a reminder that even in the cold reaches of our solar system, life may find a way. Miranda's suspected ocean could make it an ideal test case for new technology aimed at exploring icy moons. Since Miranda is relatively close to Earth compared to exoplanets or interstellar destinations, a mission here could allow scientists to refine tools and techniques for detecting and exploring subsurface oceans. This would be invaluable for future missions to places like Europa, Enceladus, or even moons orbiting exoplanets. Essentially, Miranda could serve as a laboratory for testing methods to explore and confirm signs of life beneath icy surfaces. To support life, an ocean environment typically needs not only liquid water, but also organic molecules, which are the building blocks of life. Recent research suggests that organic materials could exist on icy moons due to chemical interactions between water, rock, and heat. Miranda's icy crust, along with possible hydrothermal activity from tidal heating, could theoretically support these reactions. If organic compounds are discovered on Miranda, it would add significant evidence to the idea that life could develop on moons in our solar system's outer reaches. Miranda's internal heating might drive hydrothermal activity, similar to the hydrothermal vents found on Earth's ocean floors. These vents release heated, mineral-rich water, creating ecosystems teeming with life, even in the absence of sunlight. If hydrothermal vents exist on Miranda, they could potentially create oases where microbial life could thrive. The idea of life clustering around these under-ice thermal vents suggests that life might exist in isolated pockets across icy moons, vastly broadening our understanding of where life can survive. To search for signs of life on Miranda, future missions would need to penetrate the ice layer and possibly access liquid water directly. Scientists are developing instruments like ice-penetrating radar to map internal structures, as well as devices capable of detecting biological markers, such as amino acids or other organic compounds. If scientists can analyze samples from the ice or ocean water, they might find biosignatures indicators of life. This requires precise, miniaturized lab equipment to identify any potential life forms that might inhabit Miranda's hidden ocean. Cryobots, or ice-melting robots, are under consideration for potential missions to icy moons like Miranda. News about the potential for life on moons orbiting exoplanets, worlds that lie beyond our solar system. Many of these exoplanets are gas giants with likely icy moons. If Miranda supports life in its hidden ocean, it could mean that moons around distant stars have similar potential. The study of Miranda could thus have far-reaching implications for astrobiology and shape our approach to studying life in other solar systems. This would allow scientists to draw parallels between our solar system and others in the search for extraterrestrial life. A mission to Miranda would likely involve international collaboration due to the complexity and cost of such an ambitious project. Space agencies worldwide could pool resources and expertise to design, build, and launch the sophisticated equipment needed for such a mission. Collaborative missions have the added benefit of combining scientific perspective, including Miranda, are not likely anytime soon, but it's an exciting topic to consider. The distance, extreme cold, and harsh conditions make human exploration challenging. However, future technologies, such as advanced propulsion systems and habitat modules designed for icy moons, could make it possible. If humans ever did visit Miranda, it would likely be in the very distant future, but such a journey could open up new frontiers in space exploration, bringing us closer to understanding our solar system firsthand. The discovery of life on Miranda would have profound philosophical implications. It would challenge our understanding of life's uniqueness and could suggest that life might exist throughout the universe. Such a discovery would raise questions about humanity's place in the cosmos and could even inspire new perspectives on ethics, spirituality, and our responsibility as caretakers of life on Earth and beyond. The search for life on Miranda isn't just about science, it's also about exploring the very essence of what it means to be alive. Interestingly, studying Miranda could help us understand more about Earth's own early history. Earth may have had icy oceans and extreme environments similar to Miranda's in its primordial stages. By examining Miranda's ice-covered ocean and possible life forms, we might gain insight into the conditions that allowed life to emerge on Earth billions of years ago. This look back in time could offer valuable lessons about our own planet's evolution and the resilience of life under extreme conditions. If future missions do indeed target Miranda, scientists will have to take planetary protection seriously. This involves preventing contamination of Miranda with Earth-based microbes, as well as ensuring that any potential life forms on Miranda are preserved. International space agencies follow strict protocols for planetary protection to avoid cross-contamination. Miranda could serve as a case study and how to responsibly explore potentially habitable worlds without interfering with native ecosystems. Since any mission to Miranda would be unmanned and remotely controlled, detecting life remotely presents a unique challenge. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.